I am Adam. That is my dog Stanley, who listens to me ramble a lot about the sorts of things I'm going to be talking about for the next 25 minutes or so, and he only falls asleep about half of the time. In the past, I've been a PHP core contributor. I worked at New Relic for several years on instrumenting various runtime languages. I got a film degree somewhat by accident. And today I work at the Rust Foundation on ecosystem security, and with a special focus around supply chains at the moment. And I'm also a member of the Rust project's crates.io team, which is the Rust version of PyPI. This talk is sort of related to that work, but also sort of not, and I'm pretty much not going to mention Rust again for the entire talk because it's not really anything language specific. The title, for those who haven't somehow gotten thoroughly sick of it, refers to this XKCD. And we're just going to basically dig right into that little project, or at least try and find it. So most of you have probably heard this story already. Feel free to look at your phones or your laptops for a couple of minutes while I summarize it if you already know all this, but I'm just going to quickly put us all on the same page. So supply chain security has been obviously a buzzword for at least a couple of years, maybe a few now. But it really got thrown into sharp focus in February this year as a result of this project, XZ, which is really nice to be in Australia and be able to say Z instead of North America. It's a compression standard like gzip, Z standard, lots of others, that's been in widespread use for several years. Quite a few distros uses like their core compression format. The core of it is an open source project called XZUtils that provides a C library to handle compression and decompression and binaries to do it on the command line. Python has wrapped this in the standard library since 3.3, which was quite a while ago. So it's part of Python as well. So for most of its history, XZ has been a single-man project written and maintained by a guy called Lasse Collin, whose name I'm sure I just mangled because he's Danish. Like a lot of open source maintainers, the amount of time that he's been able to devote to his project over the years has varied a lot, right? And so a couple of years ago, he got a handful of not very friendly mailing list posts, like this one, on a very otherwise quiet mailing list, basically insinuating that he wasn't doing a good enough job of triaging bugs or responding to feature requests. And I'm just going to quote the last couple of sentences of this. "You ignore the many patches bit rotting away on this mailing list. Right now you choke your repo. Why wait until 5.4.0 to change maintainer? Why delay what your repo needs?" This is actually one of the having been an open source maintainer for many years off and on, this is actually one of the friendlier messages that you sometimes get, but it's still kind of not nice, right? Like, you're not going to walk away feeling good about yourself. I also just want to point out that this appears to have been crap, basically. Like, as far as I can tell, it wasn't falling behind, there wasn't a ton to do. So, but around the same time, a savior appeared, a new contributor called Gia Tan. Gia provided several bug fixes, was apparently very helpful, both on and off the mailing list, and probably most importantly, they weren't a drive-by contributor, right? They stuck around. They were around for a couple of years, and eventually Lasse promoted Gia to co-maintainer status, and Gia released XZUtils 5.6.0 in February this year. That release included a backdoor. Most of the backdoor was not in the Git repository for XZUtils, but it was only in the source tarbles. It is depressingly common in the C world for your source tarbles your releases to not be reproducible from the repository easily because they often include precompiled artifacts because autoconf is terrible. Mostly this is to prevent people from having to be exposed to the full horror. An aside to the aside, this is actually obviously not XZ. This is work I did in the Rust ecosystem earlier this year to basically try and look at whether packages match their repositories. Lots of every ecosystem's doing this kind of work. Python definitely is as well. I think probably the next two speakers in this room probably know of efforts that are going on right now to do this. But this is happening everywhere. The exact details of the backdoor don't really matter. It was theoretically really bad. It would have allowed essentially arbitrary SSH access to any system that it was targeting. What does matter is it was implemented just sloppily enough that a guy called Andres Freund, who was doing unrelated testing work for a distro, found it a few weeks later, critically before most distros had shipped XZ 5.6. By the way, I used Arch. It had already shipped XZ 5.6, but conveniently the backdoor didn't work, so that was good. We got super lucky on this. If this had been more competently implemented, I don't think it would have been found. We're lucky that it was kind of not super well done. And yet, in some respects, it was super well done, right? Like, somebody put in like 2 years of effort to be a maintainer on this project, and actual effort. And if you find me when I'm drinking beer later, I can tell you about the betting pool that I'm aware of for who was actually responsible for this and who the favourites are. Open source can give many eyes and make bugs shallow, but I don't think this would have been caught quickly in most cases. I think we got, as I said, very lucky, which then scares me because how many of these exist elsewhere? So that's the background. There were a couple of things that were interesting, which I've already touched on. One of them was it was kind of hidden because it wasn't in the repo. And the second one is that it wasn't an attack that was being caused by a maintainer. Like, language and distro security people have tended historically to worry more about what happens if a maintainer gets their password compromised or something like that. Like, this is why 2FA is a big thing, why Ubico has a thriving business, etc. This was someone who'd spent multiple years gaining trust to get into a position where they could do this. The call was coming from inside the house. But the thing that I also keep coming back to on this is, it's not the inside baseball security side of this. It's how this happened. If you'd asked me in January, what do I know about XZ? I could have probably told you it was, I could have told you it was compression standard. I could have told you it was a bit better than bzip, not quite as good as Z standard, something along those lines. I didn't know who maintained it. I've never heard of Lasso Column before that. I've never heard of Geotan. It's one of those libraries that gets installed by some package that's part of the base set of packages on most Linux distros and Mac OS and so on. It's something that's implicitly been part of Python for almost a decade. I'd actually like to think I pay attention to this stuff, but I missed this. I didn't know this was a one-man project from a guy who was getting heat on a mailing list about how he wasn't doing a good enough job. So it's literal, metaphorical Nebraska. So, like most of you all, I hope, I would like the things I depend upon to be stable and secure. Some dependencies are stable because they literally never change, but that's actually pretty rare. Like even XZ, which the format hasn't changed for over a decade, still had a little bit of development going on, right? People invent new distros and build systems and all sorts of stuff. So there's still going to be releases. So my contention, which I don't think is controversial, is that projects are more likely to be stable and secure if they're properly supported. We're kind of in Maslow territory here, right? I don't want an open source maintainer having to worry more about, say, housing or food as their primary concerns, and that's before we even start thinking about parts of the world where those are actually higher up the pyramid because your home is getting blown up. So that's the rub. How do we find people where they are worried about those low levels of the pyramid and where they could use some help? And what is going on in metaphorica and possibly literal Nebraska? So how do we find them? How do we find what they need? And how do we maybe help them? So I'm going to talk about this, as I said, a little bit from a Python perspective. I only have 25-ish minutes, and also Python. But nothing I'm talking about is exclusive to any one ecosystem. I'm going to guess most of us in this room, even if your job is theoretically just Python, you probably do more than just Python, right? When I've had jobs that are Python, you're still writing, in my case, it was usually JavaScript, to do front-endy stuff. So you've probably got dependencies in multiple ecosystems, multiple languages, and this applies to all of them. So let's dig a little bit into a specific project. So this project is called Zulip. It is best summarized as a fully open source Slack alternative. The Rust project uses it as its primary method of communication. And conveniently, it's written in Python with Django as the framework. So like most Python projects, we have a requirements file in the repo. It's not a pyproject.toml. It might be now, actually. It was a few months ago I looked at this. And it's even locked, which is nice. So when I'm working on a project, I usually, hopefully, know my direct dependencies, but I definitely don't know the transitive dependencies, right? That's not a layer I tend to look at. So But conveniently, we do have them all laid out, so let's dig into that. I used a tool called SIFT to generate an SBOM, software bill of materials from the requirements. The reason for doing that, in theory, you could go straight from the requirements file and dig through the PyPI API and figure out like what repo matches and things like that. Just don't. Like, you know, it's a lot easier if you use a tool that already exists for this. Zulip has 301 unique Python dependencies, which I'd actually say is on the low side, honestly. It's a different language, but crates.io, which I work on, has almost 500 Rust dependencies and exactly 1,999 JavaScript dependencies. I assume a bunch of them are like left pad and things like that, but sure. So I can use this data to basically get any other metadata I'm interested in. But here's the thing. I don't have the time or the energy to look at like 300 projects in depth, right? Like, we've got to filter this down somehow. I can look at 5 GitHub repos, but 300's kind of pushing it. I assume at some point if it's a paid thing, my boss would probably like me to do something more productive, and if it's an unpaid thing, I'd probably just like to do something more productive. And as we work through this, it's important to remember this is still incomplete, right? Like, SIFT doesn't jump to the C dependencies or the Rust dependencies if you're using something like cryptography that those Python packages have. And that's before we even start thinking about base packages in the container image, your operating system kernel. There are limits to how deep you want to go, right? Like, it's probably impossible to directly help the sustainability of, say, the people in Taiwan working at the chip fab, but you definitely at least want to be conscious of this as you start digging down. Okay, so how we evaluate this is honestly tricky. So there are scorecards out there, like the OpenSSF scorecard, that attempt to capture various metrics and quantify them. You can access this information on deps.dev, which Nikki Ringland, who I just met, will be presenting in the very next slot. But these aren't necessarily the right or only tools that are available for the job, although the raw data is itself useful. So one thing I just kind of want to touch on here is the current state of security scorecards doesn't necessarily capture all of the risks that you might be interested in. Like, if you think back to the profile of, again, XZ as an example, XZ, like I said, I would argue XZ was not a terribly unhealthy project on the face of it. Like, that maybe there were patches bit rotting on the mailing list, but I'm not really convinced there were. So it's important, a lot of these scorecards currently, because they're coming out of a security space, which is also where I work, they're very good at capturing security risks. So, are they published securely? Are the artifacts reproducible? Do they match their sources, etc.? But it's harder to capture some of the more human aspects of this. Now, to give OpenSSF their due, they're actually trying pretty hard. Like, I'll just go back to that for a second. Like, right at the top, there's code review, there's maintained. Like, these are things that are trying to capture, like, these are scores that are trying to capture, are people basically, do people care? Are people able to care about this package? But that's still, it's hard to quantify, and it's still, there were 2 categories there, and there are several more that go into this score that are more security focused. Security is important. I should probably say this because my job title includes the word security. But as I said earlier, my contention is for security to happen, you also need sustainability. I don't think you can have the security without people in good places. So trust me, when I've maintained open source projects, I already know if I don't have enough hours in the day. I know I don't have enough hours in the day, or reviewers or testing. So it's crucial to sort of understand where the problem spaces are, because it might be more complicated than just throwing money at the problem. And I'll come back to this in a bit. Although also, if you have the ability to throw money at the problem, please throw money at the problem. Maintainers would appreciate that. But you've also got to do it in the right way, because just throwing angry issues at maintainers saying, you need to do this extra security thing because, the scorecard says you need to, is actually not super helpful. The person at the other end probably cares on some level. They might say they don't because that's a defensive reaction, but they probably also have their own things they need to be focusing on. So again, I'll come back to this a bit at the end, but figuring out how to provide support is important. So Okay, so what health factors can we look at that are more that we can try and quantify to some extent? And as I said, some of these, some of these are on deps.dev and the OpenSSF scorecard. Issue count, obviously, how many issues being opened, but the actually important one is actually how many issues are being closed or assigned or triaged, essentially. How much is actually getting dealt with? Pull requests, essentially the same thing. How many things are getting reviewed, how many things are getting closed, how many things are at least getting, a comment. Something that's not from, the latest LLM hype bot that's trying to analyze it. Number of maintainers is a tricky one because small projects, the healthy number often is actually one. But if you're looking at a bigger project, if there's 100 pull requests being opened a month and there's one maintainer, that's probably an issue. That ratio is probably a problem. Recent activity level, again, this one can be misleading because if it's a stable project that's doing a stable thing, maybe there's not a lot of recent activity because it doesn't need to be. But it's something you have to be conscious of. And this is kind of related. I don't mean diversity in the DEI sense here. I just mean how many commit authors are there. And this is related to the maintainer one, but again, the ratios can kind of matter here, right? If there's 100 committers and one maintainer, maybe that maintainer needs some help. And again, just to reiterate the point, there are different shapes of projects. Like what XZ looks like is very different to what Django looks like, which is very different to, pick a project, what Twisted looks like, for example. So it's important to balance that level of scale and the level of recency, right? How active does the project need to be? If there's, if every pull request is getting closed but it's getting addressed, then, well, okay, maybe it's just a singular maintainer who has a very strong vision. That may or may not affect your choice of whether you want to continue maintaining, depending on their project, but it's valid. So I threw together some basic code to take that SBOM and just throw out the raw numbers. The OpenSSF has tools for this as well. Like the specifics of this don't really matter. I'm going to zoom in on a couple of these. I've redacted the names, basically because not that I think anybody in this room would do this. This is something I put in more for American audiences, but I don't want anyone going on a crusade, right? Just because a particular Python project has bad numbers doesn't mean that you need to go be a knight in shining armor immediately. Or as another way I put it a couple of times is do not go start geotanning these dependencies. So what did I find? Hello, lights, must be 10 minutes. A mixture of things, which is why the human element is important. So again, redacted the names. So here's a package that accepts sponsorship, has a lower commit rate recently, so you can see the percentage of expected commits is sort of lower than the historical average, and haven't closed an issue in the last month. Or they've closed some issues in the last month. They've also historically had a lot of contributors, but there's not a ton of activity right now. So on the bright side, they accept sponsorship, both the repo and the organization that owns this. So this is one where if I was in a position to offer some support, or ideally convince the people I work for, if it's a work project, to offer some support, then this would probably be a good candidate, right? This would be worth digging into further. Here's another example of a package that is probably fine. They don't take sponsorship, they've got lots of contributors, they're active, they've got a lower open PR and issue rate, they're closing issues, they're efficient, they don't accept sponsorship, and I'm kind of jealous a little bit, to be honest. So they're probably fine. And as a final example, here are a couple of dependencies from the same organization and repo. They're technically different packages. Again, I sort of look at this and I think maybe they could use a little bit of help. They do have a good commit rate. They've got plenty of contributors, but they do accept sponsorship, and they're not closing issues at the rate that you would probably hope. So again, since they accept sponsorship, maybe that's an option, right? Maybe you can kick them some cold hard cash. But again, I just want to reiterate, at this stage, we're still really just identifying potential candidates for support. At some point, you kind of have to actually engage a human element to this, or an LLM, maybe, I guess. Spend half an hour just looking at the recent issues and PRs, skim the chat backlog, and so on. Because if you've already narrowed it down to a few, then you've got the time to go do this. because the need for support doesn't always manifest as overtly as like somebody putting up the flag saying they want sponsorship on GitHub, right? I know of a Rust team, for example, right now that's struggling with lack of maintainer time, and yes, we're doing something about that. But you wouldn't know that if you weren't actually on their chat channel, because from the outside, most of those metrics actually look fine. It's just that they're clearly approaching burnout. So you don't know that just based on a scorecard necessarily. It helps you narrow it down and helps you think about what's truly fundamental to whatever you're working on, but it doesn't get you all the way to, I should actually support this or not support this. All right, so we've got a short list. We found some projects that might need some help. What can we do? Okay, if you have a budget and you can give money and they want money, give them money. Like, this is not rocket science. Obviously, it's late 2024. Money is not as abundant as it once was, alas. But, you know, if you work at a company that depends on open source software and you don't have a budget to basically support your dependencies, start finding out if you could add one. Like, ask people. I know multiple people at multiple companies who basically got this by just going and asking, and somebody in a position of power just being like, we never thought about this. Like, this is an existential thing if you're building on top of an open source stack, and everybody's building on top of an open source stack. There are also clearinghouses like Tidelift, Ecosystem Foundations, that may provide donation opportunities, but since the point of this was to find underserved dependencies in your dependency graph, chances are they probably have the same sort of blind spots you might have, because they're probably using the same scorecard fundamentally. Another option I think is often underused in the corporate world is in-kind donation. Donating 5 or 10% of an IC's time to help with project tasks is actually huge for a lot of projects and maintainers. I know personally, for things I maintain, I'm really time poor, so that's actually the kind of help I would generally like more. I mean, I also like money, but you know, practically, the time's actually more effective. Project tasks here don't mean necessarily writing code. I have a sneaking suspicion the most useful thing I ever did in open source was triaging the bug fire hose for PHP for a couple of years. Triage, documentation, community management, code reviews, design, these are all things that an individual can help with. Plus, as a huge bonus, if you, say, have someone go do code review, having someone who knows a bit about that project, even if it's transitive and 5 levels down in your dependency graph, might be really useful if you get a weird bug. Most of us probably have stories of like, oh, that one time that this bug was caused by Solaris having a weird get time of day issue. Yeah, like that's the kind of domain expertise that you can't necessarily buy, but you can definitely invest in. If you are at a larger place, sponsoring infrastructure can often be a useful way of helping projects. Open source projects of a certain size usually get pretty good support from large infrastructure providers. Definitely a little more challenging than it used to be. Again, I have stories, probably shouldn't tell them on stage, on video. But smaller projects often don't get that, and it's often not covering everything. So getting credits or donations to cover infrastructure, services, etc. can really help. But the most important thing to do is actually just to engage. Go to the person, go to the maintainer of the project, ask them what they need, send them an email. I don't think I know too many maintainers, I'm going to guess about 1 or 2% of the population, who would do anything other than be extremely grateful that you asked. You might not get an answer for a while, they're probably busy, but they definitely want to know. But if you're going to do that, you need to be in a position to follow through. Empty promises don't help, and they just waste people's time. So, you know, provide the help that you are offering, basically. So the punchline of the talk is I really lied with the title. I was a liar yesterday when I did my lightning talk on multiple levels, and now I'm a liar today. Quantification doesn't actually get you everything. It just gets you the starting point to make the judgments that you need to make to judge what to support and what might need help. I just want to suggest, you know, the point of this talk really is that we can take things that we already have, lock files, SBOMs. The dirty little secret of SBOMs is that lock files are SBOMs, really, but anyway. Use them to find the components that are the Nebraska in the dependency graph, and then go out and figure out what level of support you can provide. And even as an individual, that might just, as I said, it might just be donating some time, helping with code review, helping with documentation, something like that. Because at the end, this is a human problem, like almost every problem in tech. Well, a bunch of them are LLM problems, but most of them are human problems, which you need some level of intuition and experience with open source. And to do that, you have to show up and help. Thank you. I intend to share the code eventually, but deps.dev shares most of this anyway, so this is not as important as it used to be. But if I can spare you the horrors of figuring out how to piece together the GitHub, GraphQL, and REST APIs, I'm happy to, because I had to do it professionally for a couple of years. I think we started slightly late. I can probably take 1 or 2 questions if there are any. But again, thank you. If you like the talk, I'm Adam, and if you didn't like the talk, I'm Tom Eastman.
Thank you so much. And as a token for appreciation, this is the time.
Awesome. Thank you.
Okay, thank you so much.
Thanks.